Hello everyone, Jai Hind to all. Welcome in Digital School of Ajay Kumar Garg, Engineering College, Ghaziabad. Today in this video lecture, I am going to discuss about B tree. Before discussing the B tree, we want to discuss some basic concepts about the B tree. This is the part of trees, and tree is a non-linear data structure in which we can store the data at different level. That means if data is stored at position this, at position this, at position this, then this type of structure is called tree, and B tree is the types of trees. In tree we have discussed a number of types. The first one is binary search tree, second binary search tree, third one is ABL tree. That is the some restriction apply on binary search tree, then we have to convert it into binary search tree. And this is B tree is a types of tree, and here first we have to show the outline of the topics. The first one is introduction of B tree, second one is application of B tree, third is advantage of B tree, fourth disadvantage of B tree, and fifth one is operation on B tree. In case of operation, we have to discuss different types of operation like traversing, insertion, deletion, and searching. In this case, the first one is introduction of B tree. A B tree is a specialized M-way tree that can be widely used for disk access. M-way means this is the order. M means order of the tree. This is the order of tree. If M-way tree, then the order of the tree is M. The value of M is numeric, like 5-way tree, 3-way tree, etc. This is the types of M-way tree. A B tree of order M can have at most M-1 keys and M children. The value of keys is 1 less than the number of children. One of the main reason of using B tree is its capability to store large number of keys in a single node and large key value by keeping the height of the tree relatively small. That means this B tree is also called a height balance M-way tree, or we can say a generalized form of binary search tree. What is the mean of binary search tree? A tree having at most 2 child and the value of left child is less than the value of its parents, then the tree is called binary search tree. Here there is no issue for height. We can store value at any level, but we keep in the mind the value of left node must be less or equal the value of parents, and the value of right child is must be greater than the value of its parents. This is the concepts of B tree, but we generalize the B tree and convert it into M-way tree, and this height balance M-way tree is called B tree. There are different types of M-way tree. The first one is B tree, second one is B plus tree, but here we discuss about only about the B tree. There are some basic points related to B tree. The first point is a B tree of order M. A B tree of order M contains all the properties of an M-way tree. In addition, it contains the following property. The first is every node in a B tree contains at most M children. That means if I have a tree of 5 order, then the number of maximum child must be 5, and the maximum number of keys is, that would be 5 minus 1, 4. So the number of children must be less than the number of order. Every node in a B tree except the root and the leaf node contain at least m by 2 children. That means this is the ceiling value of m by 2 except root. This value is used for internal as well as leaf node, but we can't apply this condition for root. Root has minimum 1 keys, but in case of internal or leaves node, minimum number of order are, we can take you can talk about the number of child. The number of child is ceiling value of m by 2. We can take the decision according to number of keys also. We know that the number of keys is less than the number of order. That means the number of keys is m minus 1, and this value is represented in terms of integer. The next point is the root nodes must have at least 2 nodes. 2 nodes, that means we have to 2 children at the case of root node. All leaf nodes must be at the same level. This is the necessary condition of B tree. For example, if I have a tree like this, this is a B tree or binary search tree, then here the leaf node is this, this and this. Now this is the level 0, this is level 1 and this is level 2. The leaf, this is the leaf node, this is the leaf node and this is the leaf node. The level of leaf node is level 1 and level 2, but in case of B tree, all the leaf node lie on the same level. But here the in case of BST, the level of the leaf node is different. This is the main restriction about the MOS search tree. There are 2 main conditions. The first one is order of the tree, that means number of children is ceiling value of m by 2 and all node lie on the same level. By using these 2 property, we have to restrict MOS search tree into a B tree. This is an example of a B tree in which we take a number of value, and the main concern is that if we want to find what is the order of the tree, here we give an order of the tree. That means the value of m is 4. This tells the maximum number of child of a internal or leaves node have 4. We can't go outside the 4 because this is the order of the tree. If we talk about key values, key means the values, then the value of key is less than the value of order. That means maximum number of keys is 3. Maximum number of keys is 3. That would be root node or internal node or leaf node. In each case, we have to store only 3 value at most. And if we want to restrict the minimum number, then the minimum number according to order is the ceiling value of m by 2, that is 2. That means the minimum number of children in the given tree is 2. But we talk about the number of keys, that would be less than the number of order. Here in case of B tree, also we have to follow the properties of binary search tree. If the child left to the given element, then the value must be less than its parents. If the child on right hand side, then the value of the nodes is must be greater than the value of its parents. Here one value is 60, the next value is 29, that would be less than the 60. Now the next is the 32, then we have to take 32 after 29 in increasing order, and each node having multiple value according to order of the tree. Here 10 is the less than 29, then we have stored here. Then 23 is less than, also less than 29, then we stored here. Now 30 lies between 29 and 32, so we can store 30 here. 31 also lie between 29 and 32, then this is also stored here. Now 45 and 58, that is greater than 32, so we can store right to the 32, and that is right child of the 32. But all the left subtree value is less than 60. If the value is greater than 60, we go on right child of the 60, here 90, here 98, and the left child of 90 is less than 90, and that would be 70 and 85. The value of right child of 90 is greater than 90 but less than 98, and that would be 93 and 96. The value which is greater than 90 goes on right side of 98, and that would be 101 and 110. This is the basic concepts of B tree, and this concept is also used in case of binary search tree. But in case of binary search tree, each node having one key, but here we have to store number of key at the same level or a single node according to the order of the tree. The next point is application of B tree. In application of B tree, the first application is it is used in large database to access data stored on disk. That means if you want to store data on a database or a disk, then we have to use B tree. Second point is searching for data in a data set can be achieved in significantly less time using the B tree. Also, the searching of a given element is take less time as compared to other trees, because the height of the tree is as much low as we think. With the indexing features, multi-level indexing can be achieved. By using the B tree concept, we have used multi-level indexing. That means a single node having number of keys. According to that keys, we have to store number of value at a single point. So the indexing is also possible. Most of the servers also use B tree approach. This is also used in programming of server where the all data to be accessed. Next point is B tree are used in CAD system to organize search geometric data. Here we have to use this B tree concept in designing of CAD, where the geometric data is stored. Next point is B tree also used in other area such as natural language processing. This is the advanced point where we have to use natural language processing, computer networks and cryptography. This is the main topic where B tree are used as a organization of data. This is the main application areas of B tree. Now the next topic is advantage of B tree. B tree have a guaranteed time complexity of O of log n. This is the minimum time complexity which is used, which is calculated in a B tree. That means this is also called worst case time complexity. In this time complexity, we have to execute every operations which may be searching, which may be insertion or deletion. For basic operation like insertion, this is the main operation of B tree, deletion, searching, which makes them suitable for large data sets and real time application. Next point is a B tree are self-balancing. That means it is a self-balanced generalized binary search tree. that is discussed in a previous PPT कि B tree is also generalized form of binary search tree. Next topic is high concurrency and high throughput. This is the main point of the advantage. Concurrency is high, also throughput is also high. And last point is efficient storage utilization. That means there is no wastage of free memory. We utilize all the memory which is present inside our random access memory. Now, the next point is disadvantage of B tree. B tree is based on disk based data structure and can have high disk usage because there are number of indexing, so the null value is high. At that case, the wastage of memory is high. Not the best for all cases. It is not the best for all. That means worst case, best case, or average case, or it may be a different types of representation, and at that case there is not gives the minimum complexity for storing the data. Slow in computation comparison to other data structure. If you want to compare with graph, if we want to compare with tree, if we want to compare with stack, at that case B tree is slow. That means B tree is slow as compared to graph, as compared to stack, as compared to array. The main reason for slow is this is a index based data structure in which we have to create index for each node and store data according to the given keys value. Now the next point is operation on B tree. This is the main topic of the B tree. In case of operation, mainly we have to discuss here three types of operation: searching operation, inserting operation, and deletion operation. In case of searching operation, this operation is same as we have to use operation in binary search tree. Searching means we have to find the element into the given data is called searching. If the condition is true, then we have to print successful result, otherwise data not found. This is a tree, that means a B tree, in which we want to find 85. This is the value of data which we want to find. That means we want to find 85. Now 85 compare with root. The value of 85 is greater than 78. Move on right child. Now compare with first key. The 85 is less than 89. Move on left child. Compare with first key. 85 is greater than 82. Move on next key. Compare with next key. Data is equal to 85. Result is successful. We have to print successful result. That means data is found. Now if we want to find 49, we want to search 49, then we compare 49 with 78. 78 and 49. 49 is less than 78. Move on left arm. That means left child. Compare with 40. 49 is greater than 40. Move on right key. Compare with 56. 49 is less than 56. Move on left child. Compare with first key value of 56 and the first key value is 45. Compare with 45. 49 is greater than 45. Move on next key. Compare with 49. The data is matched with 49. Result successful, element found. This is the main searching method which is used in searching a element in a B tree. This method is exactly similar to a binary search tree. Now the next operation is inserting operation. In this case, we have to insert a given element into the given B tree. Before inserting an element, we have to check the order of the tree, the minimum number of keys, the maximum number of keys, and the level of the tree. Here, the order of the tree is 5. That means each node have maximum 5 children and number of keys is 1 less than 5, that means 4. And all internal node or leaves node minimum number of keys is 4, that is the ceiling value of 4 by 2, that would floor value of 4 by 2, that would be 2. If we take condition according to order, then we can write ceiling value of 5 by 2, that would be 3. That means number of minimum children is 3 or minimum number of keys is 2. Before this, we have discussed the relation between keys and order. Key is 1 less than the number of order. So, here if key is 2, then the number of children is 3. This is the given tree. According to insertion operation, we want to insert a node 8 into the given B tree. Here 60, 29, 32, 90, 98, 3, 5, 10, 23, 30, 31, 40 and so on, all the nodes on the same level. This also satisfies the condition of B tree. If you want insert 8 into the given tree and each node have maximum 4 keys, we can't exceed the 4, and here that a maximum keys 1, 2, 3 and 4. If the number of key increase here, we have to split the node and rearrange the given tree and make the property of B tree. We want to insert 8. First, we have to compare 8 with root. 8 would be less than 60, move on left. Now compare with 29. 8 is less than 29, move on left and compare with first key value of this node and the first key value is 3 and the 8 is greater than 3, move on next key is 5, 5 is also less than 8, move on next, that would be 10, 8 is less than 10 and greater than 5. This is the exact condition, this is the exact position where we have to insert 8. 8 is inserted at this position, but after insertion, the condition like this. There are number of keys here are 5, but according to order of the tree, the maximum keys is 4. Then what we can do? We split the node. How can we split the node? We have to take mid value and move on its parent and make 3 as 5, left child of 8 and 10 and 23, right child of 8. When move 8 upward the given level, then it may be possible the maximum value of this node we cross. At that case, we apply the same method at this node also. But here, the number of keys is 2. If we add 8, the maximum number of keys is 3. But this is the less than maximum size of the key. So, we can't split this node. We have to only split this node. This is the diagram after inserting the 8 inside the given tree. Here 3, 5, 8, 10 and 23. We tell you कि middle value is goes upside and left value of the middle value is left child of 8 and right value of 8 is the right child of 8. According to the given condition of B tree, the next tree is this 8 combined with 29, 32, and 8 is less than all these two value. So weight 8 is first, and 3 and 5 less than 8, we have to take left child of 8. 10 and 23 greater than 8 but less than 29, we mark right child of 8, and rest of the element is as it is, there is no change of rest of the 30, 31, 45, 58, and here there is no change is made because we are not inserting the element in this side. Okay. This is the main method to inserting a element into the given array. Now the next operation is delete operation. In case of delete operation, number of cases is arise. If we want to delete a element that having leaf node and the number of keys is greater than minimum number of keys, at that case there is no take the extra burden, we have to delete directly that element. But in case of deletion, if we want to delete a element which have already minimum number of keys, at that case we have to take borrow from is never, parents, or left neighbor, right neighbor, or parents. That is called sibling. Here we want to delete 53 from the given tree. The order of the tree is 5. So the minimum number of keys of internal node is 2 and the maximum keys is 4. So by using this property, we have to delete a element from the given B tree. The 53 is here. We want to delete 53 in the given B tree. First, we find out how many number of key at this node. If we delete 53, then only 57 is left. That goes below the minimum number of keys and that avoid the properties of B tree. To persist the property of B tree, we have to take borrow from its sibling, right sibling or left sibling. But here right sibling have already minimum number of keys and left sibling is also the minimum number of keys. Then what we can do? We can merge with parent. If here greater than minimum number of keys, then the list right subtree having list number goes on its parent and parents move on left side. If we want to delete with left subtree, then we move largest element to the parent and parents go on downward. But here we can't use this two property because left and right sibling having already minimum number of keys. Then what we can do? We can combine this tree with the elements. How we can combine? Here this is the tree after deleting the 53. Here single node is remaining. And this avoid the property of B tree because the minimum number of keys in B tree is 2 according to the given order. So to solve this problem, we have to merge the given node with left sibling or right sibling. If we merge with left sibling, then the tree is left biased. If we merge with right sibling, then the tree is right biased. Here we have to merge with left sibling. That means this is the situation. We have to merge these all four nodes. This is not 23, 34, 57 and 49. The sequence like this: 23, 34, 49 and 57. This is the nodes which value is shown in the final diagram. After merging the node, here the number of keys is 2. that satisfy the properties of B tree. There is a minimum number of keys is 2, and here also the minimum number of keys is 2. That is the main diagram. So in this PPT, we have to merge all the 4 elements with its parents, and these fallen tree is satisfy the condition of B tree. If this node is goes below the minimum number, then we can move one level upward. This node is combined with its parent or borrow from its sibling, but sibling having already minimum number of key, then we can't borrow from sibling. And the main concept is that we can't borrow from sibling directly. Sibling transfer the value to its parent, and parents move on downward, which is shown in the previous case. There are mainly 4 cases in the deletion. First one is a leaf node having greater than a number of keys from minimum value, then we can delete directly. If deleting a node and the right or left subtree having more than minimum number of keys, then we borrow from left or right subtree according to by involving the parents. And if there is a minimum number of keys and left and right subtree, then we combine with its parent and move on upward. But this property is persist for all the given nodes according to the given order. This is the main concepts of B tree. I give an example and draw its B tree. Like example is 1, 5, 7, 2, 3, 9, 13, 20, 50, 59. This. We suggest you draw the B tree for the given numerical value according to using property, and the order of the tree is 5. That means 5-way B tree. This is the 5-way B tree. That means order of the tree is 5. Using order, we have to find the minimum or maximum number of keys. The maximum number of keys would be 4, and the minimum number of keys would be 2. By using these 2 values, we have to draw the diagram of the given sequence. Work out on this example. If any doubt, comment on comment box. I will give you solution. Thank you. Thank you so much.